Hi friends. Today, we are going to learn how a small current can turn on an LED using a BJT transistor in a BJT driver circuit. Let's get started. Circuit overview. We are using an NPN transistor, like 2N2222 or BC547. We will connect the emitter to ground, the collector to the negative side of the LED, the positive side of the LED to a power supply of 5 volts or 12 volts using a current limiting resistor. The base to a control signal through a base resistor. Now, let's see how it works. How the transistor controls the LED. When the base is at 0 volts, no current flows into the base. The transistor stays off, and the LED remains off. But when we apply a small voltage, such as 1 volts, to the base, a small base current starts flowing. This turns the transistor on, allowing a much larger current to flow from VCC to LED to collector to emitter to ground. As a result, the LED lights up. Why does a small current control a large current? The BJT transistor acts as a current amplifier. It follows the equation. Collector current is equal to beta times base current. Here, beta, also called HFE, is the transistor's current gain, which is usually between 50 and 300. For example, if beta is 100, and the base current is 1 milliampere, then collector current is equal to 100 times 1 milliampere, which is 100 milliamperes. This means a tiny base current of just 1 milliampere can turn on a much larger 100 milliampere current to drive the LED. Why do we connect the LED to the collector? By placing the LED in the collector side, we ensure proper switching, even with weak signals. Stable LED brightness. Compatibility with microcontrollers like Arduino or Raspberry Pi. Summary. A small base current controls a large collector current. This allows us to turn on an LED using a weak signal. The transistor acts as a switch in common emitter mode. Placing the LED in the collector circuit ensures proper brightness and functionality. That's it, friends. Now you understand how a BJT driver works.